Before we get started with symmetry and rigid motions and even leading into congruence, I do want to take a minute and let people know, if you haven't already found this resource, geometrycommoncore.com. It's an incredible resource, mostly for teachers, but students alike, where there's worksheets and student notes and guided notes and assessments, all made by a teacher whose name is Mike Patterson. He's an award-winning educator from another state, but his resources are very, very thoughtful and very useful. So highly recommended there. Okay, on to symmetry here. The letter Z, line and rotational symmetry for Z. There is nothing we can do to this letter Z as far as making a line that will have it flip over itself and be symmetric on both sides. So there are no lines of symmetry for that letter Z. The heart, however, if we split it right down the middle with a vertical line, there is one line of symmetry where that heart could fold onto itself and be symmetric right to left. Now when we talk about order of a polygon or a shape, what we're really saying is how many different positions can this shape be in where it looks exactly the same as it did before. So this italics red S looks exactly the same in this position as it does in this position. So the order would be 2, because there are 2 positions where that S looks identical. This, I guess you'd call it a recycling symbol, sort of resembles a triangle, which leads me to believe that it looks exactly the same in this position as it would in this position as it would in this position, thus making the order of this figure 3. This parallelogram with a red dot exactly in the center looks exactly the same in this position as it does in this position, similar to the letter Z above. If you spun the letter Z around, just like this parallelogram, there are 2 positions where the figure looks exactly the same, thus making it order 2. Now when we talk about rigid motions, we're talking about the transformations of reflection, rotation, and translation, but not dilation, because that is not rigid due to the fact that size is changing. So it's asking us here what transformation has taken place. In this first figure, we have just rotated it, so that D mapped onto D prime. In the second figure, everything seems to be in order. We just slid it down to the right a little bit, thus making this rigid motion a translation. In question C, it looks like a perfect mirror image over a line similar to that. I'm going to redraw that line of reflection because I did not like it. That's not perfect either, but you get the idea that that triangle DCB is being reflected to make D prime, C prime, B prime. So that is a reflection. And while at first glance this might look like a reflection as well, if you notice the points do not correspond like a reflection would. The first F here, the pre-image F, is toward the top, and the image of F is at the bottom, F prime. So something else happened here. It looks like what we have is a rotation. Although it did look like a reflection at first glance, especially after looking at the last problem. Now I mentioned a few moments ago that rigid motions are rotations, translations, and reflections, and that is because distance always remains the same. Distance is preserved in rigid motions of rotations, translations, and reflections. Now when we talk about orientation, we're speaking of the order in which the points are labeled around in a circular fashion. And although a rotation turns the entire figure a little bit, the points are still in the same order, whether it be clockwise or counterclockwise, as they were originally, from the pre-image to the image. And obviously a translation barely changes at all. That's the easiest one to see that orientation remains the same. Reflections, however, because it's now labeled in the opposite direction, whether it was clockwise then counterclockwise or vice versa, reflections have a different orientation. And just to explain that reflection orientation bit a little bit further, if I was going to label from D to C to B, I just went in a counterclockwise fashion. But on the image of D prime, C prime, B prime, I followed the letters in the same order, but this time I went clockwise. So because it was counterclockwise then clockwise, orientation is different. It is not preserved in reflections. Now we saw a question similar to this on the last page. Why couldn't this mapping have been a result of a single reflection? At first glance, this does look like it may have been reflected over a line similar to that. But again, the points wouldn't match up. C would need to map onto a point near where A prime is, and that's not where C prime is. So instead, we have to find a different rigid motion, or perhaps series of rigid motions. In this case, I can do it in one step, that maps ABC onto A prime, B prime, C prime. First, you need to find the midpoint of two corresponding points, C and C prime. Now what I can do is take the original triangle, ABC, and rotate it about that midpoint so that the points map onto their images. So the answer to these two questions written out would be, why couldn't this mapping have resulted by a single reflection? Because orientation wasn't preserved. And in B, what transformation must have mapped these two triangles? I showed you that it was a rotation about the midpoint of C, C prime.